Right, let's look at loads on the body. We always say that you don't want to increase the loading or have excessive loading on the body because that results in injury. But let's just get a little bit more detail of what we're talking about when we talk about loading. So, loading is an application of a force to a body. When you're standing, when you're lying down, there's always some sort of load on your body. Tissues are loaded by both internal and external forces. An external force would be gravity. So when we're standing and moving, or contact forces, you hitting something from a fall, a jump, landing, or in contact sports, somebody else hitting you or contacting you in a way that creates a force or a load on your body. Internal loads, only muscles can actively produce force. And so muscular activation can create loads on different tissues. Connective tissues passively transfer forces. And there's only tension in tendons, ligaments, and joint capsules. So let's look at the types of loading, right? So this is where it starts to be like a one of those blooming onions. It becomes more and more complicated and yet more and more interesting. So there's not just one type of load that can be applied to the body. We have compression. So that's when the ends of the bone are pushed together, right? So you're squishing something. Tension is when you pull something apart. And again, ligaments and tendons cannot um, be under compressive load. They can only be under tensile load, right? Ligaments and tendons are like rubber bands. You can only pull them apart. We have shear, which is a parallel loads on the surface. It's kind of like a frictional, right? If you rub your hands together or your foot on the ground. That's why we have cleats, right? To monitor or control that shear loading between, say, the pitch and your shoes or the road and your shoes. There's bending. So you're kind of taking a bone and bending it at either end. Bending results in compression on one side of the bone or anything you're bending, and tension or tensile load on the other side. And I was wrong here. So if this bone is being bent to the right, there would be compression on the right side and tensile load on the left side. And then torsional loading is a twisting force. So you're taking something and twisting it, and that actually creates a shear load within the bone. These loads result in deformation. So a lot of times you'll see a load deformation curve that tries to represent the strength of any tissue. So deformation, tissues deform or they change shape based on all types of loads. So what we're trying to do when we're trying to strengthen our bones or our muscles is to control excessive deformation that could result in injury from the typical loading that we do in daily activities, sport, etc. So deformation may result from external forces, but it generally results from internal forces. So let's look at loading on the spine. And this is an interesting graph. I just want to say that 100% or zero, if you would, is based on standing. So this looks at different compression loads when we're doing different postures. So note that lying down decreases the compressive load on the spine for sure. Bending over increases it. Sitting increases it quite a bit. Bending over with a load increases it. And even bending is quote unquote properly with your knees flexed also increased compressive load. And again, loading is not bad, just excessive loading is not ideal. So the loads on the spine, we have just from forward bending or forward flexion, leaning over to pick something on your desk or leaning over to pick up something on the floor, causes your center of mass to go anterior to the spine. So you flex forward, you uh, your extensor muscles start to contract, and then we might see an anterior or posterior shear on the spine. So the previous graph, we were looking at compressive loads. The other main load on the spine is shear loading. And so here we're seeing the shear force. So if you're bending over, you're going to have an anterior shear acting down, and that's a shearing force that's trying to move the vertebra anterior relative to another vertebra. And what's helping limit that anterior shear force is our facet joints, as well as our muscle force that's creating a posterior shear force. So both shear and compressive loads will be discussed in terms of the spine, especially in the literature.